All right, what's up, everybody? This is our presentation on the structural, functional, and metabolic brain markers, how they differentiate in collision versus contact and non-contact athletes. This is being presented by Daniel Angulo.
Marlette Rossi.
Nathan Choi. Nathan Choi.
Julia de la Garza.
Okay. So for our background information, there has been a growing concern about how when playing sports that involve contact may affect the brain in a negative way. There has been research based on former athletes relating long-term brain problems and contact sports. Research has been done mostly on athletes who identify with serious health issues, which will give better results when testing them with MRIs, which were a way to see clearly if brain damage was present. Moreover, it is important to study early brain changes before symptoms appear and things could be worse. By when they study it, repeated minor hits to the head lead to affect the brain, which is why they would study these athletes before they got worse. Our introduction. This study pays heavy attention on long-term brain health on most athletes in collision and contact sports that do not show severe symptoms yet, also looking at athletes in non-contact sports. To add, studies made on former football players that are professionals have associated head impacts to depression, memory and cognitive problems, Alzheimer's disease, chronic traumatic encephalopathy, which in other words can be referred as CTE. There is hundreds of head impacts per season, which increase concern for cumulative brain damage. MRI is a powerful medical imaging technique which is to study the changes in brain structure, brain function, and brain chemistry. This imaging technique was a main tool used in this study to determine malfunctions and changes to these athletes. Moreover, there was three groups of athletes and they studied their white matter microstructure, resting brain function, and neurometabolics. Also, football players were looked at heavily since it was a heavy contact sport.
Materials and methods. So the study took 65 varsity team athletes and split them up between non-contact, contact, and collision. So there was 20 representatives for non-contact, 22 from contact sports, and 23 from collision sports. These sports included things such as volleyball, soccer, hockey, basketball, lacrosse, water polo, rugby, ice hockey, and football. They were then divided based on sex and prior concussion history. And then there was original imaging taken for a baseline to establish certain markers. The criteria for this study that athletes could not have had a concussion 6 months prior to the imaging, and they needed to be currently active in their sports. Um, so at the start of the study, they were given their preseason MRIs using an operating 3T and standard 20 channel head receiver coil. And then they were also given a sports concussion assessment tool. From this tool, they used the data to establish a baseline along with their MRIs. Um, in the MRIs, they took anatomical imaging, they looked at the white matter microstructure, they looked at the resting state brain function, and the neural metabodies. Then all of these sports, there was only one MRI taken, and then they were all compared across their different sports.
Some terminology we need to know for the data and results is going to be PLS, which stands for partial least squares analysis. This is a statistical method for modeling relationships between two sets of variables by creating latent variables. And then this was used in the study as shows the effects of contact exposure on the brain. We have DTI, which is diffusion tensor imaging, which is done in MRI. This measures the microstructure of white matter, showing a correlation between white matter abnormalities and exposure to head impacts. We had FA, which stands for fractional anisotropy, which measures is a measurement from DTI and acts as a biomarker for white matter integrity. MD is mean diffusivity, which measures the rate that water molecules diffuse in tissue. GCON is global functional connectivity, which shows overall integration across the brain. And then fMRI, which is the functional magnetic resonance imaging. So for the data, figure 1 plots PLS analysis, which results for the DTI measures of FA and MD. It shows collision sport athletes showed higher fractional anisotropy and lower mean diffusivity. Figure 2 displays PLS analysis, which results for the GCON values derived from the resting state fMRI. And GCON was highest for non-contact athletes, intermediate in contact sport athletes, and lowest in collision sport athletes. Figure 3 plots PLS analysis, which results for brain metabolite ratios. It's N-acetyl aspartate to creatine ratios per group data shows progressive effects with the highest values for athletes in non-contact sports, intermediate values for athletes in contact sports, and lowest values for athletes in collision sports. Collision sport athletes had significantly higher FA than non-contact and contact sports, giving a p-value of 0.004, while non-contact and contact groups were significantly different, giving a p-value of 0.21. You can go to the next slide. And then while non-contact and contact were not significantly different, which gives a p-value of 0.42. Significant differences were found only in collision and non-contact athletes for figure 2, which was given a p-value less than 0.001, whereas contact sport athletes could not be distinguished from either non-contact or collision sport athletes. Visual, motor, and attention functions were in the affected areas for figure 2. And for figure 3, only the difference in N-acetyl aspartate to creatine ratio values between athletes in non-contact and collision sports was significant after correcting for multiple comparisons, which gave a p-value less than 0.001. And then the discussion portion. The study suggests that significant differences in brain structure, function, and metabolism were found in collision athletes compared to non-contact and contact athletes. Collision sports detected distinct white matter changes seen in the elevated FA and reduced MD, which reflects adaptive neural remodeling due to collisions. Functions of the brain in the visual, motor, and attention departments decreased with increased contact exposure. This was shown in the GCON readings, being the lowest in collision athletes. A decrease in N-acetyl aspartate to creatine ratio levels indicates metabolic dysfunction in the brain. And then do the next slide. Even in the absence of diagnosed concussions, the findings suggest that many neurobiological changes occur in high exposure to contact sports. The data also shows while even the physiological differences between the athletes exist, the athletes themselves exhibited no clinical impairments, meaning the brain may be able to slightly adapt to the stress put onto it, and further research is needed due to the study not taking place over a long period of time.
The main takeaways from this study is that there is no significant clinical difference between the most significant was between collision and non-contact groups, but there was no significant difference. Those with previous concussion histories had increased FA and decreased GCON and MD, but these were opposite to those that have suffered severe traumatic brain injuries. And the conclusion was this could be because of the brain's adaptive tendencies.
Okay, so real world applications. So as Julia said in the last slide, from these results, it's pretty safe to say that while athletes in contact or collision sports don't show incredibly obvious symptoms, their brains are still changing in subtle ways from repeated impacts. So this means that coaches, trainers, and medical staff need to be a bit more cautious and look out for not only those obvious concussion symptoms, but symptoms that can come from the smaller or repeated hits that occur throughout normal play of these contact sports. Nevertheless, with all this being said, there are steps that we can take in order to better protect our athletes while they are competing. throughout this play of sports. So to begin with, we have better equipment or helmet designs. So with this better equipment or helmet designs, our athletes would be better protected, and this would really minimize the effects of those repeated concussion hits or those repeated head hits that could eventually lead to concussions or just other brain injuries as well. Next up, we have training adjustments. So what do I mean by training adjustments? Pretty much throughout an actual game, it might be a bit hard to really minimize the amount of head hits that somebody takes throughout a game. However, throughout practice, that is the perfect time where we could really prevent our children or these athletes from being hurt. And you already see this at times in football when instead of the coaches having them wear full pad equipment and just tackling and being completely physical with each other the entire time, they do what's called just touch. So they'll pretty much go completely padless, no equipment. Instead of tackling each other to end the play, you're simply playing what's called two-hand touch and just touching your opponent, and then the play's done. Next up, we have baseline brain scans or testing. So with these baseline brain scans or testing, if an athlete were to ever feel that anything was just a little bit off within the head or within his brain, if he went to the doctor, the doctor would now have something to look at, something in the brain or in the head to look at prior to this injury or prior to this collision occurring. And this will allow the doctors to better identify and better understand what is going on inside of the athlete's brain. And then lastly, we have overall education. This is the one that I feel is the most important and is also the easiest to really crack down on. And the reason being for this is because it's a bit wishful thinking for parents to believe that they're always going to have their eyes on their children or on their athlete 24/7. And it's inevitable that an athlete or a child is going to go ahead and suffer an injury in the head or injury in the brain when the parent is not watching. And when this is the case, it's up to the child to identify when something is wrong in the head. It's up to the child to identify when they're experiencing concussion symptoms. So because of this, I believe that education just on the topic of brain injuries, on the topic of concussion symptoms, what repeated collisions to the head can do, I feel that this education is the most important. And then this is our reference or our references for this presentation. And thank you guys for listening.